Hey everyone, welcome to this tutorial on how to perform a one-way Anova in RStudio. This tutorial assumes that you have some basic knowledge in R, so I'm not going to be too hung up on the basics here, but I will walk you through how to do some visualization of the data, as well as the full breakdown of the one-way Anova in R. First things first, let's upload the data or the packages that we need to perform some of the things that we're going to do here. So I'm going to need tidyverse, mainly for ggplot. So I'm going to load that. Reshape. I'm going to use a function called melt that I need that package for. ggthemes, this is really just a choice. It's optional. I like using ggthemes because it has a lot of different themes for how you can plot data. And then RMISC, which is a package that has, one of the functions that we're going to use here, in this case, the summarize as a standard error for one of our plots. All right, so I'm using an example from a Six Sigma Black Belt handbook that I have, and this is just simply 3 different temperatures and the moisture measurement that we have at different levels for each one of them. So the data is right here. So I have 180, 200, 220 Fahrenheit, and then I'm just using the function concatenate to have some of these values inside my data. So I'm going to run these commands. I'm basically just putting this vector or this list of values into these objects. And as I do this, you would see on my environment, my values start to show up here. My objects, I have 4 values for each. My numbers are right there. My object's naming looks good. The next thing that I'm going to do is create a data frame. So these are vectors for now. They're lists. I want to put them together. So I'm going to call it df, and using the function data frame in R, I'm going to run that command and then just see what's inside that data frame. And see at the bottom here, I simply have 3 columns with the data that I just created. Now the thing is, for us to run some ggplot graphs, we need this data to be in the long form. So what I'm going to do is to use this function melt to simply bring these 3 columns into basically having the variable and the value in the long form for the ggplots. So I'm going to call it data this time, use the function melt. I'm going to melt my df, which is my data frame, which is the 3 vectors. My ID variables is null. I don't need to identify the variables, but I will call the variable name temperature and my values moisture. So temperature will be my T180, T200, T220, and then moisture will be the values from this list. So let's run that command. And again, just check what's inside this data frame that I just created again. So as I said, now you have temperature, the different temperatures, and then the moisture values. So I simply just grabbed those 3 vectors, put into the data frame, and then I melted it all together. Have a long form so I can run my ggplots. And then before I start looking at the data, I'm going to create another object called data2. You can obviously call whatever you'd like, but I'm calling data2. And I'm going to use this function summarize se, which comes from this package here, RMISC. So what I'm doing here is look into my data and then measure the variable moisture by the grouping of temperature. So this is going to give me confidence interval values and standard error, so I can actually build some means plot. So let's run that command, and once again, just run that data2 now and see what's inside of it. As I said, you can see at the bottom here the different temperatures, the number of data points for, my mean for each one of them, standard deviation, standard error, and then the confidence interval. So these values are going to help me plotting the means plot to see, to start to look at the data before we run the ANOVA and see if it looks like they're too far apart and different from each other. Okay, so basically I have two plots here. I'm using the package ggplot. Obviously I have to inform the data set, the aesthetics, my x and y axis, and then I'm just making it pretty, really, putting a title, subtitle, caption, using the box plot first, and then using this theme. I like using these Gigi themes. They're pretty cool. It's coming from this package here, Gigi themes. I really like using this, the Economist or theme Economist, quite a bit. This is totally optional, depends on what you want to show and how pretty you want your plots to look. Let's go ahead and run this. Okay, so as you can see, the three different temperatures box plots are here. Obviously, visually, you can already tell that at especially T220, it's pretty far in terms of, you know, the median value in this case. The whiskers, although these are only 4 data points, but you can see or start having an idea of how far and variable these data sets are from each other. We're still going to run the Anova test to prove that, but I just wanted to start looking at this visually. And then the next one, I'm going to use another ggplot graph and start using this geom arrow bar. And that is why I had those calculations of the SE. So I can start using this means plot to see the confidence interval and the means between each separate group. Once again, I have code here to make the plot pretty. Title, subtitle, caption, color. I'm putting a geom line to also put a line between the means or connect the means, and again, customizing the size of the point using the same theme, Economist. It's a pretty nice plot in my opinion. So here it is. Now, kind of similar to the box plot, but now I have the mean of each group or treatment with the confidence interval. So obviously we can see that they are not overlapping at all. It's pretty much certain that this test is going to return as with a very, very low p-value, which means that we're going to reject the no in favor of the alternative. All right, to the Anova test, it only took 8 minutes. AOV, analysis of variance, that's really the function that we're using. I'm just putting this whole thing into a object called res of results.aov. I want to use moisture by temperature as my parameter here. So analysis of variance, moisture by temperature. And the data is data. I call it data. That's what it is. So if I run that command, you're not going to see anything unless you actually run the summary of that object with the analysis of variance that I just executed. So let's do that. All right, at the bottom here, you can see my results. So I have my degrees of freedom, temperature 2, which is 3 minus 1, 3 different groups or 3 different temperatures or 3 treatments. My residuals, or my error here, will be 9, and that simply is 4 minus 1 plus 4 minus 1 plus 4 minus 1, 9, in total 11 degrees of freedom. The sum of squares for the between group and the within, or the error. The mean square, which is simply this number sum of square divided by the degrees of freedom for both. And then my F value, or F statistic, which is the mean square of the between groups divided by the mean square of the within groups or errors or residuals. So that gives you the F statistic. Now I can see that this is a very large F statistic, but let's have a look at the p-value. P-value is 0.00254, a lot lower than the alpha risk set in this case here, 0.05. You can see my title here, I actually mentioned the confidence interval is at 95%, which means that it's a very, 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 very p-value when compared to the alpha risk of 0.05. In this case, we reject the null hypothesis that states that there are no differences between the means in favor of the alternative or the alternate. That would state that there is statistical significance when you look at the difference between the means of these groups of treatments. So that is it. That's how you run a one-way ANOVA in RStudio. I hope you've learned something here today, and I hope to see you again.